Alright, this is Unit 6, Video 2, Scientific Notation. So we're going to go back and forth, convert from scientific notation to standard form, just from here to here. And then we're going to go from standard form back to scientific notation. Okay. Alright, the first one's in standard form, so we want to go into scientific notation. So a couple things you need to remember about scientific notation is if there's no decimal, it's always at the end. Okay. So we have a decimal right there. And in scientific notation, you always want it in between the first two numbers. Okay, so we want our decimal here. Okay, so what I'm going to do is count. And with there's commas, it's easy to count. So that's 3, 6. So my decimal is going to move 6 times. If you don't have commas, you can go 1, 2, 3, 4, 5, 6. You're going to get the same answer. Okay, so you're going to put your new number. Okay. Don't put the zeros after the last number that's non-zero. Times 10. Scientific notation is in a base 10. And then how many times you moved your decimal is the exponent that goes with the 10. Now, think of it this way. Big numbers, like this is a large number, is going to get a positive exponent. Okay. All right, let's look at number 2. So here I have a decimal. All right, I want my decimal between the first two numbers that aren't zeros. We're going to count. 1, 2, 3, 4, 5. So I have 3.2 times 10. Now this is a small number, so it's going to be a negative exponent. All right, next one, 3. Now this looks like it's in scientific notations, but it's not. And it's not in scientific notation because when you're in scientific notation, that number has to be less than 10. Okay, so it can only have one digit in front of the decimal. Okay, so it has 2 digits in front of the decimal. So we need to move the decimal over. Okay, so I'm going to get 1.69 times 10. Now, when we do that, we have to change the exponent. Okay, and the easiest way I know how to do this is the exponent does opposite of the number. So the number went from 16 to 1.69, so the number went down, so the exponent has to go up. Okay, and you're going to move the exponent up how many times you move the decimal. We moved the decimal 1 time, so I'm going to add 1 to my exponent. So negative 6 plus 1 is negative 5. Okay. All right, next one we're going to go standard form. All right, so we have 4.2. All right, and now I'm going to move my decimal a negative 3 times. Now, think of it this way. Negative means you're going to have a small number. If I move my decimal to the right, my number is going to get bigger. So we don't want to do that. Okay, don't want to do that. So I'm going to be moving my decimal to the left because it's a negative exponent. So it's here. Move it 3 times. 1, 2, 3. Put your decimal. And then zeros go in your little loops. So my answer is 0.0042. Okay. Now next one, we have 6.8. And now it's a positive exponent. So I'm going to move it 4 times to the right. And we're going to add zeros. Okay, make sure you rewrite this because that problem has a decimal in it, so that's not a good answer. Make sure you rewrite your problems. Okay. Now this one's not in scientific notation, but I don't want it in scientific notation. I'm going to turn it into standard form. So I have 43.7, and I'm going to move my decimal 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we got to put zeros. Now when we get large numbers, make sure you use commas, okay? So my answer, 8 zeros. All right, so every 3 we have a comma, okay? And then there's your answer. Okay, all right, that's it for scientific notation. You guys have a great day.